Conference on cloning here in Washington, D.C. Next, officials from several cloning research institutes look at issues surrounding human reproductive cloning. The discussion's about an hour and a half.
All right. So if we could just quiet down. And I'd like to remind everybody once again to turn off their cell phones or watch us on the webcast. You have two choices. Now we have the next session, as you know, is cloning in humans. And I think both the panel and the participants are well advised to think about what we've learned today already, and hopefully many of the questions that came up in the morning session can be answered here. I think one of the outstanding questions that I was sort of left with was this question of how different methods of culturing embryos may lead to different outcomes, and I hope that somebody in this panel is going to address that. We will keep strictly to time. I take Anne McLaren's method as the method that's most appropriate. That is to say, when you see the red line on, I will tell you that we have finished, and then we'll go on to the next, and then we'll have plenty of time for discussion. So we, as you notice, we have a half-hour discussion. So we'll begin with Severino Antinori.
Okay.
Oh, yes, yes, yes. You guys, get down, please. Further.
I couldn't get through.
Is your mic okay?
Okay. We need silence.
Don't start yet. Just is everybody in place now? Shh, shh. Is the mic set? Okay, Severino, please.
Ladies and gentlemen, dear colleague, Professor Weisman, thank you for this kind invitation. Primarily, I want in the beginning of my lecture to explain the project, the My Consortium. 1 year ago in Rome, we organized with Professor Zavos and other members, biologists, andrologists, gynecologists, also perinatology and pediatric, the group of therapeutic human cloning. First slide, please. It's not easy to.
Can you see it?
No more. Light. But it's
Partial.
in this light, but it's wrong. Now you can see the history of mammalian cloning. You can see the first report in 1981, also especially 1996, from group of Edinburgh, Professor Wilmot, to report the first cloning with a chip dolly. Also other Yamato, other author, also Domingo and other author. Please, next slide, please. You know, I have no possibility to explain because I don't see this part. It's limited.
You want to trade places? Would it help here?
Yes.
Or if you like to move even here. Why don't you sit here?
Okay. In this slide, you can see easy the cloning procedure, recipient, donor, nuclear transfer. Next slide, please. You can see the first cloning in the mouse. Next slide, please. You can see Dolly from Edinburgh. Next slide, please. You can see monkey cloning. Next slide, please. In this slide, you can see the somatic in cell aggregation nuclear transfer. It's the particular in this procedure to obtain the stem cell for the for therapeutic cloning for other possibilities. Next slide, please. I want to explain the pre-implantation genetic diagnosis. In this slide, you can see genetic abnormality, defect, a lot of abnormality in genetic situation where we can do to perform before the embryo transfer. I want to remember, we suggest our project in my consortium is to obtain one group of the embryo in human clone, and to perform the study, the research in pre-genetic implantation diagnosis before the transfer. The first step of my project is to only study this group after the freezing and don't transfer in human. Next slide, please. In this slide, you can see there are a lot of procedure in micromanipulation. I would like to remember ICSI procedure. 12 years ago, I remember in Rome, when I published the first subzonal insemination, in this Congress, they went Professor Van Stedegen, gynecology from Bruxelles, Professor Alan Transon from Australia. In this Congress, we demonstrate the possibility to obtain in male infertility the good result with introduce the spermatozoa in egg. But a lot of people in this time, they are afraid for this manipulation. Now it's routine. Next slide, please. In this slide, you can see the pre-implantation genetic diagnosis. You can do the diagnosis with the blastoma, also in polar body biopsy, also in blastocystic stage. Next slide, please. You can see the biopsy in polar body. Next slide, please. In blastoma biopsy. Next slide, please. You can see also the procedure for reprogramming of somatic nuclear using ovoplasma. I would like to point out this procedure because last 6 months, my consortium, especially other group outside Italy, we try in animal to recloning, to use the cloning, but the recloning means use after the first blastoma another egg and second egg and third egg. But the recloning is, we suggest the possibility to elongate the time in reprogramming genetic program for reduce the abnormality. Other question. Next slide, please. About the risk, it's an important point of my election. About the risk, I want to read my paper. Several risk factors are associated with in vitro culture and reproductive cloning, and embryo from domestic animal. Culture conditions have shown to profoundly influence the development behavior of sheep and bovine embryo culture in vitro for several days. After this uterine transfer, some of them have a rise of the fetal oversize. Similarly, some of the embryo from this farm animal, when cultured with somatic cell for several days, again developing large-sized fetuses. When sheep and bovine embryo were cultured in medium supplemented with the human serum and then transferred in utero, a significant incidence of fetal and placenta anomaly, dystocia, and neonatal death, limb deformation and organ dysfunction was observed in resulting large offspring. However, the incidence of the syndrome remained neither predictable nor reproducible. Among other biological parameters, such as development asynchrony between the cloning embryo and the uterine environment, as well as placenta dysfunction, non-physiological embryo culture condition seem to be associated with and primarily responsible for the large offspring. Fetal overgrowth may also result from altered expression of imprinted gene. Recently, it was demonstrated in sheep and that large offspring fetuses originating from vitro culture embryo show a significantly reduced expression of AGF2R, concomitantly associated with reduced methylation. Biomedical study on some newborn domestic clones with phenotype alteration led to the assumption that most likely organic abnormality of energy, metabolism, neutered and created abnormal fetus, grow in poor physiological condition for extraterrestrial life. With regard to the human system, should be emphasized that during the past year of our human embryo culture for assisted reproduction, no elevate development abnormality has been observed in newborn IVF on ICSI procedure, offspring beyond and above the usual rate generally obtained among spontaneously born infants. I want to comment for this risk consideration. For avoid complete risk, in first step, we try to perform the embryo in human to study, only for study and for freezing, not transfer. In second step, in future, we suggest to perform during the pregnancy, to perform allow the possibility to investigation the abnormality of the fetus, like 10 years ago when I introduced the first baby in menopausal human. But monitoring, bilocentesis, amniocentesis, fetoscopy, possibility to bring with biopsy, ultrasound, ultrascanner, three-dimensional. Every week, study of the growth of the fetuses, we have the possibility to exclude the complete, in most of part of the possibility to transfer, to permit the birth, the baby with abnormality. Next slide, please. In this slide, you can see the telomere, one the problem in reproductive cloning. Next slide, please. Telomerase. It's this morning a lot of colleagues report telomerase is important in this problem. Next slide, please. In this slide, you can see the therapeutic cloning for produce stem cell tissue for a different situation pathology. But one pathology is a disease in testicle. When there is the man without spermatogonia, we suggest two ideas. One, the first idea to put in testicle with pathology, according with Professor Zavos, one of the most andrologists in the world. They put the stem cell cloning in the testicle for reproduce germ cell of spermatogenesis. Next slide, please. The second, you can see also the possibility to produce stem cell, for different purpose in a different pathology. Next slide, please. In this slide, you can see the motivation of application of the human cloning. Next slide, please. In this slide, you can see in my group, we checked 300 couples. I've been advised to undergo with male and donor insemination. After careful tests biopsy, when relevant complete absence of germinal line. After that, next slide, please. We performed the questionnaire. 70 of them refused the donor insemination because they are wish to transmit the gene and have requested to enter in program. Only 30% of them are afraid of the cloning because of no future risk. Next slide, please. We perform another investigation. In 100 menopausal women, we ask the same question, if you want the clone or not. Only 2% the couple were want to approach the cloning. 98% refuse the cloning and request on the enter an egg donation program. What means that? For me, generally now the position of the man is prevalent in the decision to become father or to produce a new generation. Next slide, please. In this slide, you can see quote of the patient. They generally want to have a biological child. Next slide, please. In this slide, you can see, for my opinion, for my experience, for my idea, for my program, we excluded the cloning for single woman, for couple with the other child died, or for other motivation, only to help. In the world, it is estimated about 70 million men without spermatogonia. Only for this indication. It's for me only or therapeutic cloning. Done for that use. For that, we suggest the procedure, the first step to produce the embryo, don't transfer. The second step, after this, the check and the study, to decide with the international scientific community to decide or not. Don't permit, with a lot of investigation, only one baby born with malformation. We can do all research during the first trimester, the second trimester, the pregnancy, and the third trimester, the pregnancy. Next slide, please. Indication for assisted reproductive technology, it's for offspring of non-genetic or biological related. But no round spermatid, no mature sperm we found. Next slide. Also, in this slide, you indicate for assisted reproductive technology. Until now, there is a male factor infertility. For a lot of years, my work is I work at the male factor infertility. When there is the problem oligospermia, azoospermia, we perform a lot possible to bring the spermatozoa also elongate spermatid in testing. But when we don't found out, there is the indication until now to suggest the use of human cloning for the possibility to become father and mother. Next slide, please. The cloning is complete absence of testis. It's possible to indicate also absence of spermatogenesis cell complete. Next slide, please. The syndrome, absence of test. Next slide, please. Also the certainly cell only syndrome. This estimates in the world about 70 million people without spermatogonia, without seminal cell. Next slide. Therapeutic cloning in future is play a very role in treatment of severe male infertility in the couple who have two biological child. Next slide. Indicate win for me is no identical, no physical difference, no intellectual difference, no personal difference. But I want to remember now. Next slide, please. This morning, Professor Yanaginashi reported in animal, not the same gene, not the same photocopy. Clone is genetic difference, in gestational difference, in experimental difference. Next slide, please. Okay, cloning create ordinary children who grow up the unique. Next slide.
Dr. Antinori.
Finish. Next slide. Price right reproduction, I want to point out. Next slide. Fundamental affecting person is where the birth of the child. Next slide.
So that's it.
Finish. Thank you for the
Thank you very
attention.
much.
Thank you for your attention. I am open for discussion.
Thank you. Dr. Zavos.
Thank you very much for the opportunity to be here today. After this morning's session, of course, we're en route to bigger and better things this afternoon. May I have the first slide, please? The new frontiers in assisted reproductive technology, ARTs. Next slide, please. I have known Professor Antinori for almost 17 years. And since then, of course, we have collaborated quite heavily, I should say. As we all know, infertility is a disease. And up to almost 4 to 5%, or even more than that, suffer from male infertility. And even greater than that, they suffer from female infertility. So in the US, we use a rule of thumb as being 20% both male and female infertility is a realistic figure. And those couples obviously need some sort of an assistance in order for them to bear children. May I have the next slide, please? Let's skip that one and let's go to the next one. Some of the causes of male infertility is fevers and infections, surgery for reproductive tract damage, the vas deferens, etc. So in other words, there's a great deal of variation in the types of difficulties that the male may have that prevent them from having a child and may need assistance in order for them to reproduce. Next slide, please. Causes of female infertility, cervical hostility, tubal factor, anovulation, endometriosis, age, etc. Next slide, please. In vitro fertilization was introduced 23 years ago by Robert Edwards and Louise Brown was the first child conceived from such effort. Low sperm count or motility, in vitro fertilization, of course, is prescribed, and the success rate is approximately 30 to 35% in the U.S. today. Next slide, please. Intracytoplasmic process, or intracytoplasmic sperm injection, I should say, ICSI is otherwise known. Various other individuals are going to talk about this later on, and therefore I'm not going to touch upon those, but ICSI is a modality via which we can treat very severe infertility difficulties. Next slide, please. During that, testicular sperm extraction can be done, and at this time, I think on that CD, somebody has, you need to go to the NAS2 slide version, not anything else. Are there any other sets of information on that? I have two versions of slides, and I think this is not the one that I should be using today, but anything goes. I've got another CD here if you can find that.
It says NAS August. This is file for that.
NAS2, please. That's what I said this morning.
Switch computers. Hold on. Yeah.
I apologize for this. I modified my speech after I spoke to several people this last week, and I'm supposed to have NAS2. NAS2. Just a minute. If you can find it on that CD, I have another one.
I just wanted to send a message to Anne. That's right.
Send it to her.
Mechanisms for doing this are great because you can change your slides right up to the minute before, but I don't think they'll ever be totally this happy.
Are we ready? Okay. Okay, thank you.
That's why.
Yeah, remember.
Yes. So you knew that, did you?
She did.
I see. I did. I see. So somebody needs to. We need to. Yeah, we need to make it very clear.
NAS2, there it is. Fourth from the bottom.
I know, but you know, the trouble is it's all sort of. I know, but the trouble is it's sort of got into the public.
The cheering team.
You see,
I apologize for this. Let's just roll the slides, please. Okay, let's stop right here. The history of cloning, of course, a lot of us covered this issue quite heavily today, but it starts in 1981, embryonic cell nuclei transfer, inner cell mass, that is, and then we went into the sheep and the cows and the pigs and the goats and the human, of course, the human being embryo splitting, no transfer has attempted. In the next slide, please. And there you see also we went to the monkeys. Don Wolf and company has obviously worked very heavily on that. And as you see, a whole conglomeration of species have been exploited and the technology has been developed. Now there's more to do, and as the scientists alluded to this morning, the beat goes on, the research goes on. Next slide, please. Let's say hello to Dolly. Next slide, please. How Dolly was created. This slide obviously tells us very analytically that the mammary gland cell was obtained, it was placed into an enucleated oocyte. The electrofusion was applied, and then of course an embryo or embryos were produced. And from those 29 unscreened embryos, it was transferred in 13 ewes, and 1 out of 13 got pregnant, and the pregnancy rate was 7.7%. Next slide, please. Now let's look at the mathematics here for a moment. Reconstructed X277, embryos created 29, 13 transfer recipients, and the dolly was produced, and all 29 unscreened embryos were transferred into recipient ewes. Now, we do not know exactly, and maybe Dr. Wilmot would tell us this afternoon, as to what was the number of embryos transferred in utero per animal, because that's very important. In the humans, we do know exactly how many embryos we should transfer to get a pregnancy, and preferably a normal pregnancy. Next slide, please. A number of studies have already demonstrated far higher rates, although the groups that have published heavily so far, they alluded to the fact that there is a great deal of deficiency, and the statistics don't really measure up to. Several of the scientists that spoke this morning, I think that they have alluded to the fact that a great deal of success has been accomplished. Now, there's more to be done, but when you get 30 and 40 and 50 and 80%, that I call success, because today in human IVF, you get only 30% success, and you're happy if you do that. And therefore, that is what we call success in the assisted reproductive technologies with human reproduction. Next slide, please. Again, animal cloning efficiency is very low, according to Dr. Wilmot and Dr. Yenish, published in Time magazine this year. But although we feel like while the number of cytoplasms utilized is relatively high, what reason is there to think that this will always remain so? And I think the scientists during the next to the last session this morning answered that question very, very vividly. Next slide, please. Now, there is evidence of that. Embryos created 141 by a group in China via serial cloning here. This is the recloning process. Out of that, 45 live births occurred, and the success rate is 32%. Again, I remind you that human IVF today in the US gets 30% success. This is 32% success rate. The next slide, please. There is a group in Japan. The numbers may not stack up as much, but most of the animal cloners do talk very seriously when they have 10 animals or so, because they regard that as very clear evidence. Therefore, embryos created 10, live births 8. The success rate by Dr. Kato in Japan is 80%. Now, like we say in Kentucky, this ain't hay. This is 80%. Next slide, please. Now, some of the difficulties noted by animal cloners is poor cloning response, poor implantation and pregnancy ratio, and poor health of the animals born. Now, let's go to the next slide, please. Those difficulties are due to poorly designed experiments, poorly executed experiments, poorly approached experiments, poorly understood and interpreted experiments. And I had to say that, but some of them were done for fame and fortune. Next slide, please. The problems lie in the areas of tissue culture cells used in SCNT. And I think that the scientists addressed this morning. Improper perfection or unprogrammed cell lines, improper understanding of the reprogramming of the genes after the SCNT, complete lack of embryo screening of the clone embryos prior to embryo transfer, developmental asynchrony between transferred embryos and uterine environment, and persistent use of highly inbred animals that are susceptible to genetic aberrations during SCNT. And I think that those are very, very direct target areas that I think that we in the human and the animal reproductive arena need to address in order for us to begin to address and perfect those technologies. Next slide, please. Next slide. Okay. I want to address a paper that was recently published by Dr. Wilmot and Yanish in Time as well. SCNT is not copying, although they do say that they're copying, because we do not copy someone when we clone someone. And I do realize that when they talk about their animals that they clone, they do not use the term copying. But when they say something about human reproductive cloning, they're talking about copying. Why? Because they want to confuse the issues. And this is really very, very important, that we should not be confusing the issues, but rather directing those issues and make the public aware of the fact that we're not perfect, but we're trying to get there as perfectly as we can. Next slide, please. Okay, there are many social and other factors why we should never be in favor of cloning a person. Dr. Yenish and Wilmot boldly, obviously, indicate that SCNT will never be acceptable and will not be obviously applicable. Although we feel like that this technology can be developed and can be made safe for people to use for reproductive purposes. Next slide, please. Okay, on the same issue, anyone who has given rational thought or thorough study to the matter understands that a child that has been the result of SCNT will be a unique individual. And Dr. Wilmot himself has indicated that the lambs that are born from SCNT do behave differently, which is obviously an indication that those animals that are cloned of Dolly's sisters and brothers and whatever, next of kins, they do behave differently, and therefore they're different. And that should be the issue with humans as well. Next slide, please. Now, they're also going further to say that there is every reason to believe that human cloning experiments announced by myself and Severino Antinori will never be successful. And they base that on that paper saying that circumstantial evidence begins to hint at defects of reprogramming of gene expression in cloned animals. Obviously, I must tell you that in Kentucky, you do not get arrested for DUI based on circumstantial evidence. Therefore, we cannot, as scientists, make statements like that in the public saying that Severino and I cannot do this, and they're basing all that on circumstantial evidence. You just can't do that. Next slide, please. Let's examine the facts further. Fact one, it should be noted that no form of embryo screening methodology has been systematically really employed by most of the original human cloning efforts. Next slide, please. Several studies have been published demonstrating the birth of healthy living animals, and I think that this was demonstrated very clearly this morning as well. Next slide, please. There is every reason to believe that if we continue to refine those technologies, and I think that it was also revealed very clearly this morning, we will get there, because very simply it's a matter of determination, and I think we are determined to get there. Next slide, please. Additional screening methodologies will be developed in order for us to be able to screen the tissue culture cells in suspension, the reprogramming process, and the pre-implantation embryos and post-implantation embryos and fetuses in order for us to yield a normal, healthy child as we see it and as we believe in the human reproductive arena. Next slide, please. Epigenetic instability of ES cells and in cloned mice. This is a paper that was published, and it is really hot off the press, as I label it as such, where they're claiming that the variability of gene expression is, in these mice, likely reflects epigenetic changes that occur during in vitro culture among sister cells derived from a single cell, and notion that the epigenetic state of ES cells is extremely unstable. In other words, here it is a study that sets out to study cloning, and then all the epigenetic or the genetic aberrations that they were to be obviously introduced and studied occurred in tissue culture, which means what? That we, as serious scientists, if we're going to study cloning today, we better stabilize and develop a good tissue culture system in order to grow those cells first, maintain them in a stable environment, and then transfer them and study those phenomena. But we cannot just cook something and say, well, it smells good, or it doesn't smell good, then we are not going to serve it, and we're going to be publishing information that is very, very, very confusing to the public. I need to emphasize that this study was published 2 weeks before the Congress deliberated and voted against reproductive cloning and stem cell research for that reason. Because they're afraid, they're scared, and they're uninformed. as the public says. Next slide, please. Let's go to the next slide. In that same paper, which of course has been published about 3-4 weeks ago, they say that no significant correlation between the anomalous fetal growth and clone mice and abnormal expression of any single gene was seen. If you read that paper, you see no correlation coefficients in there. There are absolutely no correlation coefficients. Again, they're drawing conclusions, they're presenting that, and believe it or not, that day that this paper was published, and it showed up in press, I was confronted maybe with 50 or 60 of you folks calling my office and say, what do you think about this? And of course, there are probably thousands of you that reported this paper as being hot off the press, and that we ought not to be doing human reproductive cloning because we're simply is not safe. But what does this paper say? Very confusing results. Next slide, please. Next slide, please. Let's go to the next one. Let's go to the next one. Okay, I want to point one item out. I had my embryology group go in and do some due diligence research, and we found out that obviously this paper, when I said this morning that it was published about 91 days after it was submitted in Science. Normally, a peer review publication,
Dr.
and
Zavos?
I'll finish in a second. We reviewed about 30 publications in the latest issue of Fertility and Sterility that shows that it took 10 to 12 months for a peer review paper to show up in Fertility and Sterility. And there it is, an issue that appeared in 91 days in the press, 2 weeks before the Congress deliberates.
Thank you for your contribution,
very
Dr.
much.
Zavos. Dr. Boisselier?
Thank you for your invitation. I'm not sure that I should thank you actually, but thank you actually to have to allow so many positive results to be published and to become public today, because I believe that we had very positive results published this morning. I will not show any slide because I knew that I will change my talk with I wanted to hear this morning, and so you won't have anything to read. But we won't lose time at the same time. I'd like first of all to say, what is the purpose, to answer the question, what is the purpose of human cloning? Because I think it's something that we should remind ourselves. Why are there 3 people here and maybe some others outside that are not public that are doing it? Because there is demand. There is a huge demand. There are a lot of people who like to have a baby using that technology. There are people who cannot have a child with their own genes, and they have heard about cloning, and thanks to the research that was done at the Roslin Institute. And now they have hopes. If there are hopes, if there is a technology, you should be aware that this will be done. So we should not forget in our debates that there is that huge demand. Further down the road, I believe that our society is changing a lot, and science is behind this change in our society. I think one day we'll be able to use our genes the way we want, and I think it's our own choice to use our genes the way we want. If you want to have a baby, mixing your gene with someone of your choice, it must be your right. But it's also your right if you want to reproduce yourself using your genes alone. And I think this will be debated in our society, but science is behind that. Now, what scientific data that have been provided to us today and in the past publication that support the banning of human cloning? What do we have today that we should consider? Because I consider myself as a responsible person, and I will not clone a human being expecting some kind of defects. So I had to review all this information and make my own decisions on how I should proceed as a scientist. Well, we heard a lot about defects. The first one that was the most public was the overweight of Dolly. And I was glad to hear that it was a media effect, actually, this morning. But I was treated as a media hog in the public recently, so I should take care of my weight, maybe. But Now, regarding the rate of success, because people have been saying this is terrible to produce or to think of producing a human baby with such a low success rate. Let's talk about success rate in human reproduction. Today, if there is a new couple would like to have a baby, they decide to have a baby, sometimes they can wait very, very long, and my colleagues here will tell you that some people could try for years without having that. They have severe infertility problem. But if we only consider individuals or couples who do not have infertility problem, they are trying to have a baby, they can wait sometimes a year, sometimes 2 years to get a baby. What does that mean? Does that mean that they only have one embryo produced and only leading to one pregnancy? Not at all. We know that they are producing embryos every month or every cycle, and they have early miscarriages. What does that mean? Those embryos were not viable. So in sexual, normal, so-called normal reproduction, there is a success rate of about 10, 12. It's not enough documented, but it's easy for us to visualize that there is a low, very low sexual reproduction success rate. Now, if you look at in vitro fertilization, then you raise that success rate up to, for most of the clinic, between 30 to 40% success rate. And even I think there are some clinics are going up to 50% rate. So by science, we control, in human reproduction, we control a lot those defects, those possible damage, because they are means to check those embryos. And these have been developed for the last 22 or 23 years, thanks to in vitro fertilization. Now, so this is for human reproduction. Now if we go to animal cloning and the success rate that we heard about, so it's true that there was one publication at 80%, but most of the success rate, as was summarized actually by Dr. Coleman, are between 0.5% and 19%, which is very close to actually this normal sexual reproduction. If we only use numbers, remember those numbers, so today we have those. This is for the rate of success. How to compare animals and human? Can we use the results of the scientific results on cloning of human and apply those to human? Because that's what is done most of the time, and that's probably also the purpose of this meeting. First of all, if I look at the results between species, there have been presentations this morning showing that there are defects in some species that are not observed in some others, and vice versa. Some are overweight, but some are not, and some have placenta problems, some do not. So between species, there are differences. So how can we use the results, the defects in species, in the whole animals, and take all the different defects in all the species and say, we'll have all of them maybe applies to the human cloning, since there are already differences between species. It's just a master of reproduction in every species, because the knowledge in reproduction in mouse is different from the knowledge in reproduction in cows and in pigs and in sheep and in human. And if we compare those knowledges, I believe, and I think I'm not the only one to believe, that the species where we have the most knowledge in reproduction is certainly human. So to me, to compare those defects, or to use those results on animal cloning and apply them and predict defects in human cloning is difficult to apply, just considering the differences between species cloning. There are also a lot of knowledge, and my colleagues talk about that, in how to monitor pregnancies and all the very heavy equipment and huge amount of money that have been introduced into that development of pregnancy monitoring in human cloning. we talked about diagnosis, we talked about epigenetic problems, and there were also differences in the results that were expressed this morning. For example, Dr. Yeni Gamashi, I'm sorry about the name, I hope I'm not, my name is difficult too, so epigenetics, he showed that actually there are epigenetics differences, and they explain the defects based on those epigenetic differences and the problems in the imprinted genes. But at the same time, there have been publications showing that there are differences in epigenetic or imprinted genes in very healthy clones. So today, there are no consensus to say that actually those imprinted genes are responsible of anything regarding to those defects. So in my understanding of what was presenting, that there is no explanation of those defects today, and they are very different depending on the species. And there are no explanation also on natural defect reproduction in human cloning. Why are those couples waiting so long to get a baby? So today, I'm not saying that we should consider those defects, but we should concentrate on how to control the defects. And how can we control that is indeed in working very hard in the preparation of those embryos. And I believe that we could spend 10, 20 years in improving the cloning of the sheep or the pigs or the cows or the mice without learning anything about the cloning of human. Because they will be very specific on the improvement of the knowledge in reproduction of those animals or those typical species. Now, what scientific challenge do we have, or did we have at Clonaid when we started and during our process? I wanted to answer both aspects of those debates on unhuman cloning. First one is how to prepare a viable embryo, and the second one, how to diagnose whether this embryo is viable or not. So the team has been working on both aspects, the preparation on the reproductive way, or a reproducible way, I'm sorry, to produce embryos and find the right media and the right culture media. And the other one is to make sure that we can detect viable embryos. So I will not reveal all the results. As you know, this is a private company, and we have restriction on what we can publish. But I hope to give publication very soon of our results, especially on the diagnosis, because we believe, and I always feel. I've been reading all the publication about those results on genes imprinting and so on, and we have developed very serious diagnosis to check on imprinted genes and see how they are, even if there are absolutely no correlation between the defects and the imprinted aspect. But we gathered a lot of information about that, and hopefully we'll be allowed to see how this correlates to the defects. So, to conclude, do I have any concern about harm that should be done to a child or to a surrogate mother or to a mother who would carry a cloned child? Considering what I've been hearing and that my team have been producing in the lab, I do not have any concern. I'm a responsible person, and I feel very comfortable with those results and with the knowledge that we have accumulated for the last 22 years, but also very recently on this technology. My main concern is actually in the health of our scientific community. I think we shouldn't be accomplice of public emotions or public fears. We should, on the contrary, fight for such research to be done in the best places. I'm not saying that I'm the best, but I'm saying that I'm doing it. I'm doing it in a very responsible manner, in a very conscious way. And I wish that this research could be open to the large public and be because there are hundreds of scientists who would be willing to do it and are not allowed to say it in this community because they will lose their grant, their reputation, and everything. That's what happened to me. Another concern is certainly the arrogance that we may have to tell people what they should do with their own genes. I think I'm going back to the demand. The demand is huge. The demand is there, and this will be done. And I hope it's done properly in a very safely way. I'm doing it, and I hope that I can publish that very soon and share that with you all. This is all.
Thank you, Dr. Bosselier. We are now open for questions. I'll start myself. So before we had this session, we had extensive discussions, as you know, on the issues of how would one do a diagnosis of a pre-implantation embryo to know whether it was suitable for implantation in pregnancy. And I didn't get an answer when I heard all three of them, so I'd like to ask if any of you have a method, for example, of scanning whether imprinting or reprogramming has proceeded correctly, or if you think that that's no longer a problem for some reason. Anybody?
Reprogram program, they establish the procedure. In this project for the pre-implantation diagnosis, we can do this project, we can do with use all possibility in pre-implantation diagnosis. And at the same time, after freezing the embryo, study what happens in the future after the second step. And when we'll decide to transfer the embryo, instead to synchronize the transfer of the embryo in cavity of the uterus in the human. Second step is to perform the villocentesis after 11 weeks, every week to perform the monitoring with the growth of the fetuses, also the study in part of the apparatus, to continue the study until the second trimester.
So, just a sec. So, do you mean to say that you will examine the state of differentiation, methylation, gene expression?
Methylation, gene expression, other things. Until now, there is not a lot of experience, but a lot of report. The last it's from Zan and from another group. Maybe culture conditions necessary to increase, to change, to check other culture conditions to avoid this. But it's now, until now, it's impossible to extrapolate the wrong methylation, the epigenetic change, the short telomere, but necessary to continue the study. Because for me, for my experience, in pharma animal, in animal, the results in IVF, it's at the same time we use the culture media, you have the same abnormality, the same result. But when you use the recloning, the last work from Zamme and also from Monica, mission from Zavartenko, the result is completely different in comparison to Professor Wilmot. It's a very low, malformation rate, a very good pregnancy rate. Like
So,
the
if we could keep our answers a little briefer, does anybody else want to answer this question? Because I have now a lot of questions.
Yes. I like to elaborate on it, and let us agree that there's no test for 30,000 genes that we can do in an embryo that is obviously the result of reproductive cloning. Therefore, there is no such test. And we all know that there are possibilities of defective expressions and gene expression, that is, that cannot be assayed for. However, we do know that if the reprogramming issue is an issue, then what we as scientists will do is actually aim to perfect the reprogramming process via development of proper tissue cultures, utilizing the proper cell populations for the reprogramming, and then furthermore, of course, is to apply the PGD information that is available today to us in order to screen those embryos for pre-implantation genetics. That's about it.
Thank you. So now here's the questioners that I have in order. Singer, McCabe, Gallus, Yanish, Charo, Robertson, Coleman, and then we'll start again. Dr. Singer.
Do you have an answer?
So, the first question I'd like to ask is for Dr. Boisselier. I can appreciate that because you're involved in a private enterprise, you don't feel free to tell us about the kinds of results you're getting, or even some of the methods that you may be using. On the other hand, the job of our panel is to learn as much as we can about what is going on and what the promise and problems are with the proposed technology. And so in the interest of that, I would like to push you just a little bit and to see if you would be willing to tell us what kinds of diagnostic tests you are using without your having to feel obliged to tell us the results.
Okay. Well, it's close to the question of Dr. Weissman, actually. You know, I've been reading all this publication about imprinted genes, and so we developed a diagnosis to check. Among the human beings have 42, is that correct? I think most of the 42 human genes are imprinted that could be checked in the early stage. We didn't develop for the 42, but we can do in a routine about 10 of them and see how reproducible they are imprinted or not. And so I was really interested by Dr. Yanish's results since he has been checking 6 genes on a routine base and see a lot of variation. And we, depending on the media culture, on the process that we're using, we have very reproducible imprinting results.
What is it you're checking about the imprinted genes?
Whether they are imprinted or not. But what I mean is that whether they are expressed or not in that.
You're looking at expression?
Yes, we do. So what I'm saying is that we have reproducible data today that could be publishable, and we hope that we will be able to publish soon.
And you're checking expression on single cells from a blastocyst?
From single cells, yes.
And is this after somatic cell nuclear transfer? I'm a bit confused.
That's what I assumed.
Yes, of course.
That's what I assumed. Sorry, Bridget.
I see, yeah. So you have done somatic cell nuclear transfer into an empty egg. You've developed them to 4 cell, 8 cell? You've taken a single cell, and you've looked at imprinted boxes of 10 genes.
This is correct.
Okay, Dr. McCabe?
I'm curious about, as you undertake the human trials on this, to what extent will you inform the participants? What are the kind of issues that you will raise in your informed consent process with the participants, and how much will you use the animal data in that informed consent process? Any of the speakers.
We obviously, we do take the animal data seriously. But as Dr. Boisselier and others have alluded to this morning, is that there is a species-to-species variation. Therefore, those variations are very important for us to point out that those are all possibilities. Now, should we concern the patient? Of course. We do inform the patient that this technology is not safe. It cannot yield 100% healthy children. It cannot produce 100% results, positive results, that is. And that is really what we do today on a routine basis with IVF, with in vitro fertilization. From the time of the application of medication, the fertility drugs that they could hyperstimulate, to the time that we do the oocyte, the aspiration of the follicles, that they could obviously, they are undergoing an invasive technique, and they could suffer some very severe ramifications out of that, to the time that those embryos are manipulated in vitro, and they can obviously be transferred and yield some sort of an abnormality, or some sort of that the success rate, if the woman is above 35 or below 35 or above 40, all those statistics are shared with the patient, and the patient will not undergo any procedure in a medical setting as an IVF setting it is today, unless the patient signs a series of consent forms. And therefore, the same will apply when this technology will be made available to the humans.
So, just a sec, did you say that you will include the data of the animal cloning?
Of course we will.
Okay. So next is Dr. Gallis.
Yes, this question is for Dr. Boisselier. I appreciate your advocacy of research in this area, and this is really a follow-on question to a couple of the others. Putting it a little bit differently, what would you consider to be the key or the highest priority research issues from your point of view that the community at large, not just yourself, should be investigating at this stage?
Well, I do believe that we have enough information today to proceed and do the human cloning. Okay, the whole debate has been in the comparison between animal cloning and human cloning, and to answer those, there will be a lot of research to do, to show whether they are right or not. But the only way to do it is to produce that and to implant and get human embryo, clone human embryo implanted. Because I do believe that we have everything we need today to proceed. And they could certainly do a lot of research on other animal and other species, and that will not help for human cloning, because we are dealing with different cells, different culture media, different imprinted genes, so many different things. So we need to proceed with the human cloning in order to find out, to really get the final stage, because I don't think that working on animal cloning will give us a lot more information. Of course, there will always be information given, always that, but today we have enough to proceed. That's my, reviewing all what have been published, and in regard with what was said this morning, and in regard of what we have been doing in Clonate, I think we have enough.
Can I just follow that for a moment?
I wanted to clarify one thing. So you did just say a few moments ago that you have developed a method to look at the expression, or I guess methylation, I'm not quite sure which, of somewhere between 10 and 42 of the genes. Does that mean that if you don't get appropriate methylation, you will not go forward? Is there a stopping point there?
Absolutely, of course.
So yes. It has to be a perfect, or 9 out of 10, or 8 out of 10?
It has to be completely reproducible in 100%, yes.
Okay. So if we could, pardon me, sorry, Dr. Zavos, you wanted to answer also?
I wanted to say that, each species has some advantages and disadvantages. For instance, what we've heard this morning, it was a potpourri, if you will, of information here that tells us that the animal cloners are really making a great deal of progress by doing it within those species. But at the same time, they're researching at this time something that we have very good grasp on, for instance, on the tissue culture medium. Two different cultures produce two different size calves, for instance, and there's variation in the growth of those calves due to variations in the tissue culture. And we've been doing tissue culture in human embryos and human oocytes and human sperm for 23 years. Today we have specialized media that we can grow a day 1 embryo, day 2 embryo, different media for that, different media for day 3, different media to grow the embryo to a blastocyst. We have media that can mature an oocyte. We have oocyte maturation media. We have media for preparation of gametes for IVF prior to fertilization. We have media for ICSI. We have so many different developments in the human arena that it's going to take a while for the animal cloners to catch up with that. Now, in order for that to catch up and still remain, leave a very wide window open here as to does the information that we generated in the mouse apply in the human? That's always going to be the question. So we do hear the animal cloners. We do hear those statistics very, very clearly. But unless we do it in the human, we will never have a human set of data to discuss at a forum like this.
So, Dr. Zavos, do you use also the same kinds of tests like gene expression and imprinting and so on? And do you have results with your media that says that you have reproducible patterns of early developmental expression of genes?
Let me make one point perfectly clear here, is that we have never done a human clone embryo as yet. We're in the process of doing that. We're studying all possibilities, and we're obviously gathering information that is going to assist us in getting there in the most efficient way. To answer that is, no, we do not have the types of results that Dr. Boisselier is referring to. We only have traditional IVF, ART information on the PGD, on the quality control of embryos, on all the aspects that we have set up to do in the human reproductive arena, synchrony of endometrium to the transferred oocytes or the transferred embryos, all this information that is really very key in establishing a healthy pregnancy and carrying that healthy pregnancy to term and having a healthy child born from such effort.
Thank you. Now, Dr. Janisch.
Thank you. I think I need to correct a few factual errors, Dr. Zavos. Wilmut and myself do not publish in Times Magazine. We publish in Science.
Okay.
So this article which you referred to was an editorial we wrote in March, and Ian and I decided to write this because we're concerned about your activities and we wanted to bring this to public attention.
So that was in
Time
Magazine
let me finish.
when I quoted.
Let me finish. That was an editorial, it was not peer-reviewed. We indeed quoted their circumstantial evidence. Now, Dr. Zavos, the scientific process is to gather data, try to convince yourself that you can make conclusions and convince yourself that you can publish this. At this point, we had some preliminary data that told us there was misexpression of genes in cloned animals, but we were not ready to publish this. We were ready to publish this in April. We submitted this to Science, it went to peer review, and the peer reviewers apparently liked it, so it was published in July. So this is the normal process of scientific research. This is a normal process
your
of
questions
research.
Before you continue to the next one, because I'm not going to allow you to lecture to me.
Let me finish.
Well, this is a question and answer session.
No, you'll get plenty of time to answer the question.
So I think I just want to get your misconceptions.
If he has a question, I will answer it. If he has a comment, I will comment as well. And then we'll continue.
I want to answer. Please. I have the right to play. Attention.
Excuse me, the chairman.
Can I finish my comments?
There is me.
No, if it's a comment, no.
Again, you clinician, but impossible to extrapolate the result.
So let me
with the veterinary biological result in animal project in human system. It's necessary to explain these people.
Dr. Antinori,
there is only 3 people with experience.
Let me go to the facts here.
If it's not a publication and it's an editorial, as a scientist, you should know better than editorializing.
So
please, you're out of order right now.
The paper was published in July. That is indeed a paper. And there were evidence, we were sure about this data. So you're right. We attributed the defects in the clones to pre-existing variation in the ES cells. That was the purpose of the paper, to explain the difference between stem cell-derived clones and somatic clones. And that was and I totally agree with you. In human cloning, you will not use embryonic stem cells. There's no use in this. However, as I said this morning, we again have circumstantial, if you want so, I would call it preliminary evidence.
No, it's circumstantial, it's not preliminary.
Preliminary evidence that cumulus cell clones, so cumulus cells are never cultured. They're taking out of the embryo, and this was done together with Jan Megachi's laboratory. Taking out of the embryo, the nucleus is isolated, transferred into the oocyte, and you derive a cloned pup from a cumulus cell derived nucleus. all right? When we look in those for gene expression, this is not preliminary evidence. I'm not ready to publish this because this is a very complex experiment. You probably don't realize how difficult these experiments are to interpret them the way that you know what you're doing, right? So we try to do that. So we have preliminary evidence that indeed when we look at gene expression in these cumulus-derived clones, that there's lots of dysregulation. Some is similar to ES-style clones, some is not. Some imprinted genes are dysregulated, some are not. We have to understand this. So this is very important, and that's what we call preliminary. That's in general use in science. So I think, Dr. Zavos, you're missing the crucial point. You're mixing it all up. The crucial point,
I got your paper here if you want to review it.
And I don't want to review it, I know it. The crucial point is, can you really pre-screen embryos for abnormalities? And we heard we can use very sophisticated techniques like scanner, single or multicolored, something. I think this is about as effective to detect reprogramming errors as the opinion of uninformed couples about the cloning process. It is ineffective. You cannot do that. I think I have summarized before to you, it is impossible at this point to look at those defects, the genetic abnormalities, which I agree clinicians can detect very efficiently, are not the problem. These are the subtle problems of reprogram which cannot be done. So, and the final point I want to make is that it is no question in my mind. Yes, there are species differences between all the 5 species, there's no question. But the basic biological problem, that of reprogramming, there's just no doubt about, it's a fact, is absolutely similar in all mammals, and humans are mammals. So the basic problems are the same, and they are unresolved,
it may not
and they're
be
not resolved at this point.
That you're describing it, sir. So it may not be.
So if I finally finish then, I think it is wrong, to my opinion, to focus exclusively, as apparently you do, on imprinted genes. Imprinted gene dysregulation is part of the problem. It is not the problem. It's part of it. Imprinted genes, I believe, indeed contribute to the growth abnormalities, but they're not the only ones to do. And we have evidence, preliminary evidence, as you like it or not, preliminary evidence that non-imprinted genes are dysregulated, and they probably contribute to this phenotype. So I think we're at the stage where we just do not know all the ins and outs and all I think the extent of the problem which we have. And in this time, to say we're looking at 3 different genes and then we conclude the embryo is normal, I think this is not good science.
So if I could... I do got answer, excuse me. Dr. Janic, I want to answer. We perform pre-implantation diagnosis, but also I am gynecologist, no, you're not gynecologist. After 6 weeks or 10 weeks, I perform willocentesis, other diagnosis. It's necessary to understand. It's necessary to inform that. We exclude, every week we check whether, do you know the method of ultrasound diagnosis with the body in fetus? You know, Mr. Quinmot, respect experience with the gynecologist in this reproductive medicine. I respect the veterinary farm animal work. Thank you.
Dr. Charo. Dr. Charo, I got you. Dr. Charo? Oh, yes.
I wonder if you could help me understand if there is any risk too great or any reason too trivial for you to agree to a cloning attempt in a human being. Or are you suggesting that there is no role for professional medical judgment in deciding whether to accede to an informed patient request to try cloning?
I'm not sure that I understood your question. Would you be kind enough to repeat it? And put that microphone just a little bit closer to you.
I'd like to understand better how you view the role of a medical professional working with a patient who has been given information and has made a request. And so I'm asking if you think that the medical professional should always agree to give a patient what she has requested or he has requested after proper information, or if you think that there's a role for professional medical judgment concerning a risk that you think is too high or a reason for cloning that you think is too trivial.
I am not an MD, but obviously I do work with MDs all the time. And I can only tell you that we would never, and I mean never, ever risk the patient's health, general health, to achieve something. Between Severino and myself, we probably go 50 years plus in the infertility market, and we have never produced an unhealthy child. Especially I admire Severino because he can get a 62-year-old woman to give birth to a healthy child, which means that it's not an easy assignment by anybody's definition, but he can do it because he knows what it takes to get there. And
Dr. Zavos?
Yes.
Okay, I'm going to move on so that we get all the questions in. I think you answered that question.
Thank
you. Dr. Robertson.
Yes, the impression the panel gives to many of us here on the podium, and I'm sure in the audience.
Is that on?
And in the audience is that you're being quite radical in wanting to proceed with human cloning at this point when the state of the science is so uncertain. However, I actually heard Dr. Antinori say something that I thought was quite conservative. And I wanted to check to make sure I heard it correctly and want to know if the other members of the panel agree with that. And the statement that I heard that I took as quite conservative was that your interest in cloning and your use of cloning, if it were shown to be safe and effective, would be only for that narrow group of infertility patients who cannot produce healthy gametes, that you would have no interest in using it for any other purpose. Is that in fact correct, Dr. Antinori? And do the other members of the panel share that very limited use of cloning once it were shown to be safe?
I can answer that
first Dr. Antinori. He was asked.
I don't understand very well because...
let me answer it. I think that
repeat, please. I don't understand because... Please.
We both harmonize here. We belong to the same consortium for reproductive medicine, and I can only assure you that our consortium at least stands very firm on that we will make this technology available only to people that have exhausted all other possibilities for reproduction.
Attention, I want to answer, excuse me. I suggest two options. When do you have the male infertility without the spermatogonium, like Sertoli syndrome only? We have two possibilities to apply the therapeutic cloning. To put the stem cell cloning in testicles, another option to transfer gene with the somatic cell with the clone, proceed with the recloning. For me, but it's preliminary. It's necessary to try the research in stem cell cloning in testicles when there is detected without spermatogonia, without nothing.
We are in danger of not getting all these important questions.
I'd like to answer. Is that possible?
Dr. Boisselier.
Oh, yes.
Okay.
I couldn't see you.
Yeah, because I think we are not on the same line with my colleague. I do believe it's a fundamental right to reproduce yourself the way you want. And if you want to mix your gene with somebody else and have a baby, with either because you have a mate or you have a partner, or you buy eggs, or you buy sperm, it's your choice. But if you want to reproduce yourself by cloning, it's also your choice. As long as you're not producing the same person as yourself, you are producing your belated twin. But this is not science, this is more psychology and
right. So if I could move on now, we have only one-sentence questions and one or two-sentence answers. Dr. Coleman.
Yes, this is a very complicated technical area where it's easy to fool the public. Now, I think it's incumbent on all of us around the table to try and represent data as accurately and as unbiased way as possible. Now, in your talk, Dr. Davos, you showed data from a Japanese group where they put 10 blastocysts back into cows, yes, had 8 births. You omitted to say that 4 of those animals died shortly after birth. I can only infer from that either you didn't know this data, which was in the same paper, or you regard the death of 50% of the liveborns as something which can be tolerated for humans.
I didn't say that. I am saying that the success for IVF today is only 30%. And obviously, we're not interested in extrapolating or duplicating the calf data that either you produce or the Japanese are producing.
Okay.
We are obviously merely reporting the facts as they appear in the literature.
I want to point out, do you know the work was done with 32% pregnancy rate? Why don't mention it in your work, in the work of the professor of the Zan reporting in the last publication, 32% pregnancy rate in goat. Why don't mention it?
So on to the next is Dr. Siegler.
I want to know.
Dr. Siegler.
Yes, I'd like to address my two questions to Dr. Zavos.
One question.
Closely linked.
I can only give you one answer anyway.
I'll be very quick about them. It sounds as if the panelists are likely to proceed soon with human cloning, despite the animal data that raises concerns and worries about it. In that respect, my two questions are this. Number one, do you intend to be entirely transparent, that is open with the public and the media, as you go forward with the first case? And second, what will it take your group to stop human cloning? What kind of bad outcome would be sufficient in the first several cases to lead you to change the position that you've presented today?
We obviously believe, at the consortium, we believe that if we cannot do it right, we will not do it. That's to answer your second question.
That doesn't answer my second question.
Well,
my second question is, what kind of bad outcomes, deaths, disabilities, morbidities, in the first case or the second case?
I think it does answer it. It's just that obviously, you know, you want me to label all those kinds of things. I said, if we cannot do it right, we will not do it. And I think that's very appropriate for your answer. Please say that you're satisfied.
No, I'm not satisfied. I don't
then that's all you're going to get.
I think it's
question
clear
number
that's all
one.
we're going to get. Doctor, you got
Can I answer his first question?
Quickly. Yes, quickly.
Go ahead.
Hello, I want to replay the project for the human cloning. It's the first step is to produce embryo in a human clone. We don't decide the transfer. We already studied the human clone for studied a lot of problems in abnormality genetic. The first step is this. The second step, after 6 months, after 1 year, I don't know, but we will be sure, we will careful in this work. We maybe consider, but one thing is important: to synchronize the embryo transfer in correlation development of the embryo, because in animal there is no reported like in this field. In animal, don't check the embryo. In human, before they involve the birth or the delivery, we need a lot of investigation.
I'm going to take two questions from the panel and then see what I can finish here, but I want to make sure the panel gets it. Dr. Singer.
Can I answer it, Dr. Ziegler?
If you can make a very short answer.
I think your first answer needs I mean, your first question needs an
Dr.
answer.
Boisselier.
Let me answer it.
No, Dr. Zavos, this is Dr. Boisselier is going to answer the question that was unanswered.
Yeah, you wanted to know whether we would stop if we had scientific evidence that this is very harmful for human beings. I would say that if we had reproducible defects in early stage human embryo, I will go back to the initial nuclear transfer and make sure that to repair that, but it will not stop.
Dr. Singer.
Yeah, I have one question. I'd like to clarify something. If I understood correctly, as Dr. Robertson mentioned, Dr. Antonori said that he would restrict his efforts to cases of male infertility. Since we've been talking about informed consent on the part of the people involved and education of those people with respect to the risks and dangers, I wondered how you're going to do that, because it seems to me that the two individuals who are at risk are the woman who carries this fetus and the baby who may or may not be born, whereas the person who wants the cloning done and gives the genes is a man, and he is not at any risk whatsoever. And I wonder how you deal with that issue.
The same question posed 12 years ago the Cardinal Tonini in Rome. When I put the injected spermatozoa in egg, he told me, Antinori, do you want to destroy the membrane what the God put at protection? Now, with support Professor Van Stedeke, Alan Trons, and micromanipulation, I just published. X is a procedure. You fair, it's motivate, because I just demonstrate that my careful in my work, in my life, all time when you use, I want to avoid possibility to complication, to abnormality. I want to inform, or to answer, I don't use. I am not sure to permit to continue the pregnancy if there is some abnormality.
Yeah, I think it's a different question you answered, but I'll move on now to Dr. Donahoe. Dr. Donahoe.
I would like to say that translational research, work that has been, you might have established at the bench and are now ready to take into a patient, is done with great fear and trepidation. And with the confidence that it has undergone peer review scrutiny. My question is, do you think that any form of human cloning has had sufficient scrutiny of peer review?
I am, obviously, I have published somewhere in the vicinity of 450 peer review publications, and therefore I am very much aware of that, and I serve on editorial boards of various journals. And I must tell you that I believe in that. However, the way that the circumstances evolve in the human cloning arena is not going to be possible for a number of reasons. First of all, if the politicians are going to behave the way that they do, and they close the doors on true scientific investigation as you and I know it, and they're going to force the scientists to develop this technology in clandestine laboratories, if you will, then I think that we're not going to expect that kind of behavior to take place, because we're simply, any type of behavior of that type has to be a two-way street.
Dr. Zavos,
you don't arrest us, we'll share our results.
No, I think that the peer review that you were mentioning is like an institutional review board?
Yes,
IRB.
or
IRB.
Or any other review of the manuscripts or otherwise.
Dr.
It makes no difference.
Dr. Transon.
I mean, Dr. Basilier's claim that she can measure these imprinted genes in embryos is ludicrous, really, because I don't think that's at all possible. But there are a whole lot of non-imprinted genes that are expressed or not expressed at the right time that are a problem, and we've published on these in Biology Reproduction, and so you can't just stick to the imprinted genes either, even if you could measure them. But what I want to ask Antinori and Zavos is, if we worked out a way of creating an artificial gamete for you, haplodize a somatic cell, would you give up cloning? Would you not do it anymore? Would you do that if we proved it was safe?
I forget, but in the first we will consider this research is very interesting, from to put before the cloning, to use another opportunity, other different possibility. Like,
so if there are other ways of correcting male infertility, you wouldn't do the cloning procedure?
Yes,
that's correct. Yes.
Dr. Sibeli, right there.
Thank you. I think it's important to remember that there's a lot of people listening to this, and many of them are not scientists. So the main point I want to make a difference is that Dr. Antinori, he mentioned that you call this therapeutic cloning. And that can confuse some people, because we were calling therapeutic cloning the process of making stem cells, and we'll never transfer those into a uterus. So which is to the chairman and the panel to know that we have to make a distinction between what we call therapeutic cloning or non-reproductive cloning and what you call therapeutic cloning.
Well, but it is a form of therapeutic cloning. So it does treat somebody's disease.
Sure, it doesn't matter how you call it, but we have to make a distinction what you're pursuing and what we are pursuing.
I take that as a clarification. The final is Dr. Momberts.
I would like to inject a little point of moderation here. I see a lot of negative claims here about clones. I am not afraid of clones. I'm not afraid of an attack of the clones. All the mice that I've ever seen and played with, they're healthy mice, they're lovely mice, they reproduce, they don't die of unknown diseases, they don't get tumors, they have a normal lifespan. Many mice die at birth, but those that survive are by and large normal. And somehow this is getting lost here, I think, today. We're maybe going too far in genetic reductionism and say if a mouse doesn't have a proper expression pattern, then it's not normal. But the mouse may not care.
So what kind of test would you suggest?
I would like to see, and this has not been done sufficiently, decent immunological analysis, immune responsiveness of cloned mice, pathological analysis, behavioral assays, with proper controls. Those are not easy to find. Unfortunately, that hasn't been done. Those things don't get published in Nature and Science, unfortunately, but they take a lot of work. But I contend that most mouse clones are normal, unless proven otherwise.
So I would like to thank the panel and the participants and the speakers. We've obviously gone on much longer. We now have until 10 to 2, and we'll come back. Thank you.
How do you think this debate plays into it, and why is it important at this debate? Well, there are similar discussions in Canada in the springtime of the scientists, by and large, also supported by the Canadian Institute for Health Research.
Percent the couple where you want to approach the cloning. 98% refuse the cloning and request on the enter an egg donation program. What means that? For me, generally now the position of the man is prevalent in the decision to become father or to produce a new generation. Next slide, please. In this slide, you can see quote of the patient. They generally want to have a biological hour child. Next slide, please. In this slide, you can see, for my opinion, for my experience, for my idea, for my program, we excluded the cloning for single woman, for couple with the other child died, or for other motivation, only to help. In the world, it is estimated about 70 million men without spermatogonia. Only for this indication. It's for me only or therapeutic cloning. Don't for that use. For that, we suggest the procedure, the first step to produce the embryo, don't transfer. The second step after this, the check and the study to decide with the international scientific community to decide or not. Don't permit, with a lot of investigation, only one baby born with malformation. We can do all research during the first trimester, the second trimester, the pregnancy, and the third trimester, the pregnancy. Next slide, please. Indication for assisted reproductive technology, it's for offspring of non-genetic or biological related. No round spermatid, no mature sperm we found. Next slide. Also, in this slide, you indicate for assisted reproductive technology. Until now, there is a male factor infertility for a lot of years. My work is I work at the male factor infertility. When there is the problem of oligospermia, azoospermia, we perform a lot possible to bring the spermatozoa also elongate spermatid in testing. But when we don't found out, there is the indication until now to suggest the use of human cloning for the possibility to become father and mother. Next slide, please. Thermal cloning is complete absence of testes. It's possible to indicate also absence of spermatogenesis cell complete. Next slide, please. The syndrome, absence of test. Next slide, please. Also the certainly cell only syndrome. This is estimated in the world about 70 million people without spermatogonia, without seminal cell. Next slide. Thermal cloning in future is play a very role in treatment of severe male infertility in the couple who have two biological child. Next slide. Indicate win for me is no identical, no physical difference, no intellectual difference, but no personal difference. But I want to remember now, next slide please. This morning, Professor Yanaginashi reported in animal done the same gene report the first cloning with a chip dolly. Also other Yamato, other author, also Domingo and other author. Please, next slide, please. You know, I have no possibility to explain because I don't see this part. It's limited.
You want to trade places? Would it help here?
Yes.
Or if you like to move even here. Why don't you sit here?
Okay. In this slide, you can see easy the cloning procedure, recipient, donor, nuclear transfer. Next slide, please. You can see the first cloning in the mouse. Next slide, please. You can see Dolly from Edinburgh. Next slide, please. You can see monkey cloning. Next slide, please. In this slide, you can see the O plus somatic in cell aggregation nuclear transfer. It's the particular in this procedure to obtain the stem cell for therapeutic cloning for other possibilities. Next slide, please. I want to explain the pre-implantation genetic diagnosis. In this slide, you can see genetic abnormality, defect, a lot of abnormality in genetic situation where we can do to perform before the embryo transfer. I want to remember, we suggest our project in my consortium is to obtain one group of the embryo in cloning, human cloning, and to perform the study, the research in pre-genetic implantation diagnosis before the transfer. The first step of my project is to only study this group after the freezing and don't transfer in human. Next slide, please. In this slide, you can see there are a lot of procedure in micromanipulation. I would like to remember X procedure. 12 years ago, I remember in Rome, when I published the first subzonal insemination. In this congress, they went Professor Van Stedegen, gynecologist from Bruxelles, Professor Alan Transon from Australia. In this congress, we demonstrate the possibility to obtain in male infertility the good result with introduce the spermatozoa in egg. But a lot of people in this time, they are afraid for this manipulation. Now it's routine. Next slide, please. In this slide, you can see the pre-implantation genetic diagnosis. You can do
conference on cloning here in Washington, D.C. Next, officials from several cloning research institutes look at issues surrounding human reproductive cloning. The discussion's about an hour and a half.
All right. So if we could just quiet down. And I'd like to remind everybody once again to turn off their cell phones or watch us on the webcast. You have two choices. Now we have the next session, as you know, is cloning in humans. And I think both the panel and the participants are well advised to think about what we've learned today already, and hopefully many of the questions that came up in the morning session can be answered here. I think one of the outstanding questions that I was sort of left with was this question of how different methods of culturing embryos may lead to different outcomes, and I hope that somebody in this panel is going to address that. We will keep strictly to time. I take Anne McLaren's method as the method that's most appropriate. That is to say, when you see the red light on, I will tell you that we have finished, and then we'll go on to the next, and then we'll have plenty of time for discussion. So as you notice, we have a half-hour discussion. So we'll begin with Severino Antinori.
Okay.
Oh, yes. 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 You guys, get down, please. Further.
I couldn't get through.
Is your mic okay?
Okay. We need silence.
Don't start yet. Just is everybody in place now? Shh. Shh. Is the mic set? Okay, Severino, please.
Ladies and gentlemen, dear colleague, Professor Weisman, thank you for this kind invitation. Primarily, I want in the beginning of my lecture to explain the project, the My Consortium. 1 year ago in Rome, we organized with Professor Zavos and other members, biologists, andrologists, gynecologists, also perinatology and pediatric, the group of therapeutic human cloning. First slide, please. It's not easy to.
Can you see it?
No more. Light. But it's partial. This light, but it's wrong. Now you can see the history of mammalian cloning. You can see the first report in 1981, also especially 1996 from group of Edinburgh, Professor Wilmot, you can do the diagnosis with the blastoma, with also in polar body biopsy, also in blastocyst stage. Next slide, please. You can see the biopsy in polar body. Next slide, please. In blastoma biopsy. Next slide, please. You can see also the procedure for reprogramming of somatic nuclear using ovoplasma. I would like to point out this procedure because last 6 months, the My Consortium, especially other group outside Italy, we try in animal to recloning, to use the cloning, but the recloning means use after the first blastoma another egg and second egg and third egg. But recloning is we suggest the possibility to elongate the time in reprogramming genetic program for reduce the abnormality. Other question. Next slide, please. About the risk, it's an important point of my election. About the risk, I want to read my paper. Several risk factors are been associated with in vitro culture and reproductive cloning, and embryo from domestic animals. Cultural conditions have shown to profoundly influence the development behavior of sheep and bovine embryo culture in vitro for several days. After this uterine transfer, some of them have a rise of the fetal oversize. Similarly, some of the embryo from this farm animal, when cultured with somatic cell for several days, again developing large-sized fetuses. When sheep and bovine embryo were cultured in medium supplemented with the human serum and then transferred in utero, a significant incidence of fetal and placenta anomaly, dystocia, and neonatal death, limb deformation and organ dysfunction was observed in resulting large offspring. However, the incidence of the syndrome remained neither predictable nor reproducible. Among other biological parameters, such as development asynchrony between the cloning embryo and the uterine environment, as well as placenta dysfunction, non-physiological embryo culture condition seem to be associated with and primarily responsible for the large offspring. Fetal overgrowth may also result from altered expression of imprinted gene. Recently, it was demonstrated in sheep and that large offspring fetuses originating from vitro culture embryo show a significantly reduced expression of AGF2R, concomitantly associated with reduced methylation. Biomedical study on some newborn domestic cloned with phenotype alteration led to the assumption that most likely organic abnormality of energy metabolism in utero and created abnormal fetus grow in poor physiological condition for extrauterine life. With regard to the human system, should be emphasized that during the past year of our human embryo culture for assisted reproduction, no elevated development abnormality has been observed in newborn IVF on ICSI procedure, offspring beyond and above the usual rate generally obtained among spontaneously born infants. I want to comment for this risk consideration. For avoid complete risk, in first step, we try to perform the embryo in human to study only for study and for freezing, no transfer. In second step, in future, we suggest to perform during the pregnancy, to perform allow the possibility to investigation the abnormality of the fetus, like 10 years ago when I introduced the first baby in menopause human. But monitoring, bilocentesis, amniocentesis, fetoscopy, possibility to bring with biopsy, ultrasound, ultrascanner, three-dimensional. Every week, study of the growth of the fetuses, we have the possibility to exclude the complete in most of part of the possibility to transfer, to permit the birth, the baby with abnormality. Next slide, please. In this slide, you can see the telomere, one the probe in reproductive cloning. Next slide, please. Telomerase. It's this morning a lot of colleagues report telomerase is important in this problem. Next slide, please. In this slide, you can see the therapeutic cloning for produce stem cell tissue for a different situation pathology. But one pathology is a disease in testicle. When there is the man without spermatogonia, we suggest two ideas. One, the first idea to put in testicle with pathology, according with Professor Zavos, one of the most andrologists in the world, they put the stem cell cloning in the testicle for reproduce germ cell of spermatogenesis. Next slide, please. The second, you can see also the possibility to produce stem cell, for different purpose in a different pathology. Next slide, please. In this slide, you can see the motivation of application of the human cloning. Next slide, please. In this slide, you can see in my group, we check 300 couple. I've been advised to undergo with male and donor insemination. After careful test biopsy, when relevant complete absence of germinal line. After that, next slide, please. We perform the questionnaire. 70 of them refused the donor insemination because they are wish to transmit the gene and have requested to enter in program. Only 30% of them are afraid of the cloning because of the no future risk. Next slide, please. We perform another investigation. In 100 menopausal women, we ask the same question, if you want the clone or not. Only two